So for this video, we'll be talking about the cardinality of sets. So first, when we refer to cardinality of sets simply refers to the number of elements in a set. So say if we have x equals AB, then its cardinality is simply 2, since x has 2 elements in it. So now, let's talk about 2 important formulas that we will be needing in solving some examples relating to cardinality of sets. First, we have the cardinality of the union of A and B is given by the cardinality of set A plus the cardinality of set B minus the cardinality of their intersection. The reason behind this, why not just adding them? Well, the reason behind that is that when we have 2 sets that have a common element, when we simply add A and B, say we use the color orange for A, so it would contain this part. This is A. And using red for B, this would contain this part. Now, as you can notice, the part in the middle was counted twice out here, since it has the orange part and the red part. That's why this one is needed for sets that aren't mutually exclusive. So now we have, next is the cardinality of the power set of A. So the power set of A simply refers to the set of all subsets. So if we're given again the set X containing A, B, its power set is first the empty set. Since empty set is always a subset of any set, we also have X. Since X is always a subset of itself. We also have the set containing only A and the set containing only B. So as you can notice here, we have 1, 2, 3, 4. We have 4 elements. The reason behind that is because the formula for the power set, for the cardinality of power set, is given by 2 raised to n, where n is the cardinality of the set A. So for this case, there's 2 elements, so 2 raised to 2 is 4. So these 2 are the 2 formulas that we will be needing in solving the examples later on. So first example, suppose that 35 students joined the math club. Let's denote math club is letter M. And 50 joined the science club. So this one, letter S. If 15 students join both, how many students will be there when the 2 clubs join? So for this example, first we have 35 students joined the math club. So that simply refers to the cardinality of M is equal to 35. And the cardinality of S is 50. We also have 15 students join both. So when we refer to both, we simply refer to their intersection. So we have 15 students since both. So now, how many students will be there when the 2 clubs join? As mentioned a while ago, the formula in getting the union, the cardinality of the union is given by the cardinality of M, the cardinality of S, minus the cardinality of their intersection. So if you're confused why we're taking the union here, since we are asked about when the 2 clubs join. So that's simply in a diagram. It refers to this one. When we refer to this one as a whole, so that's simply a union. So for this, we have first the cardinality of M is 35, the cardinality of S is 50, the cardinality of their intersection is 15. So when we add this, first 35 plus 50 is 85, minus 15, that would give us 70. So the number of students when the two clubs join will be 70. For our next example, we have how many subsets are in the set A if A is equal to the set containing red, blue, and yellow. So we could take our time in creating the power set. That's simply the empty set, set A, containing red, blue, yellow, and all that. But that would be problematic if this already contains 4 or maybe say 100 elements. What if this is already 100 elements? This would be a problem in solving if we try to list them all. So as mentioned a while ago, the formula for this one is simply 2 raised to n, wherein n refers to the cardinality of A. Since we have, in this case, 3 elements, this is simply 2 raised to 3, which is equal to 8. Now for our third example, given the set X, which refers to the letters in calculus, and Y, which is the letters in algebra, what is the cardinality of their union? So first we note that set X refers to, so the letters in calculus, that's C, A, L, C, U, L, U, S. But note that we will remove the letters C and L and U out here, since it is redundant in this case, since we already have C, L, and U out here. So removing that, will give us this set out here. So this is the set X. For the set Y, we have A, L, G, E, B, R. And we won't repeat A, since A is present here. So we know that X union Y is equal to the set containing C, A, L, U, S. A is already present, L is already present. So G, E is not yet present, so we put E here, B, and R. So counting its elements, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the cardinality of their union is simply 9. For a fourth example, we have in a class of 30, 2/3 said they like trigonometry. If 10 of the class liked both trigonometry and geometry, how many likes geometry but not trigonometry? So first, a class of 30, this refers to their union, since we're only dealing with 2 subjects out. So that's let's refer to this one as T and this one as G. So this is T union G. Now we have here 2/3 said they like trigonometry. So how would we solve this 2/3? So that's simply, since we have the total number of students as 30, so 2/3 of 30 is simply 2/3 times 30. So cancelling, we'll be left with 10. And so this is equal to 20. So we now know that the cardinality of T is equal to 20. Now we also have extent of the class, like both trigonometry and geometry. So we again have the keyword both and n. So that is simply T intersection G is equal to 10. So let's first simplify some things here to avoid confusion. So what we have so far is the cardinality of their union is 30. The cardinality of students who like trigonometry is 20. The cardinality of their intersection is 10. So we are asked to find the number of students who only like geometry but not trigonometry, or simply the cardinality of G. So rearranging the formula we have, but let's first move this out here to give us some space. So with the formula we have, we know that their union is equal to cardinality of T, cardinality of G, and the cardinality of their intersection. So we can rearrange this by, since we're finding this one, what we can do is we can move this out here and this one out here. So that will give us the union minus cardinality of T plus the cardinality of their intersection. So since we already have their details, simply put this one as 30, this one is 20, and this one is 10. So we have, putting down their signs, we have 30 minus 20 is 10, plus 10 is 20. So we now know the number of students that's like geometry alone, not trigonometry, not including trigonometry. For last example, we have, this one is more complex, but it's still solvable. So we have, there are 40 members in the club. Each member is part of at least one group in the club. Group A, B, and C. 7 are part of groups A and C. 12 are part of B and C. And 4 are part of all. If group A has 18 members, B has 27 members, and C has 20 members, find the number of members that are part of both groups A and B. So the problem seemed lengthy, but we first have this one, 40 members in the club. So that refers to the total number. It's 40 members. But since each member is part of at least one group, we know that this is also equal to the cardinality. Let's use this as our notation for sets. Representation for our sets. So this is also equal to the cardinality of A union B union C. Aside from that, we also have 7 are parts of group A and C. So that is the cardinality of A intersection C, 7. We also have 12 are part of B and C. So we have this one, and 4 are part of all of them. So we have A intersection B intersection C is 4. Now we also have the per group. So group A has 18 members. We denote it this one, and B has 27 members. So we have this one, and lastly, C has 20 members. So we are now tasked to find the number of members that are part of both groups A and B. So both groups A and B refers to this. So let's put it out here to avoid confusion. So we are finding this. So to solve these types of problem, what we can normally do is first we create a diagram for it. So say we have this diagram out here. Let's first move this one to get it out of the way, and this. So let's refer to this one as let's refer to this one as set A, this one as set B, and this one as set C. So the technique for this one is you start with the innermost part going out, then this one here, there, and there. So inside to outside. So first we have this one, their intersection all is 4. We also have A intersection C 7. So this part must be equal to 7. Since we already have 4, this is simply 3. Then we also have the intersection of B and C, which is this part. This we already have 4. This is simply 8. And this part is unknown to us. So we put X out here. Now we also have the next part, which is, since this is only this 3 are the only one left. So we have A contains 18 elements. Since this one refers to the whole set A, then A is equal to 18 minus X minus 4 minus 3. And this is simply 11 minus X. We also have this one to be equal to 27 X minus 4 minus 8. And that is simply, this will be negative 12, 27. So that would simply be 15 minus X. For this last part, we know that C is equal to 20. So we have 20 minus 8 minus 4 minus 3. So it's 12 minus 3. So that is, this is negative 12 minus 3, 20. So 20 minus 15 will give us 5. So this part is 5. Now, the problem is we don't know the value of X, but we can solve that since we know that A union B union C is equal to 40. Or when we add all of this, the outcome is 40. So since we know that, let's move this first out of the way. Since we know that, we have 40 is equal to 11 minus X is 1 plus X plus 15 minus X plus 3 plus 4 plus 8 and plus 5. So simple algebra, you can do this to solve for X. So first, note that negative X and X here would cancel out. We have 11 plus 15 to be equal to 26. We have 3 plus 4 equals 7 plus 8 give 15 plus 5 give 20. So 20 plus 46 would give 46. So the whole constant for this part would be 46. since we still have this one left x, just to take note. So 40 would now be equal to 46 minus x. So transposing this one over here, we have negative 46 plus 40 equals negative x, which is equal to negative 6 equals negative x, or x equals 6. So the question is this one the final answer? The answer is no, since we are tasked to find this, the cardinality of A union B, intersection B, but it refers to this one. Since this is 6, the cardinality of their intersection is x plus 4, or 6 plus 4, 10. The answer is 10. So that's all for this video.